Hello class, today's lesson is on how to find the least common multiple. Today class we're going to talk about finding the least common multiple, abbreviated LCM. Well, what is the least common multiple? It's the smallest term that is divisible by all terms in the group. In other words, it's the smallest term that all other terms will divide into with no remainder. There are several steps that we have to take in finding the LCM of a term. First, we want to factor each term completely. Secondly, we want to choose each factor that shows up. We want to pull the highest power, the one that has the highest exponent. And thirdly, we want to form a product of the factors chosen, and this product is our LCM. So let's look at an example. First of all, we're going to look at an example of finding the LCM of constants. So suppose we want to find the LCM of 24, 36, and 40. In other words, we want to find the smallest number that 24, 36, and 40 will all divide into. A lot of times students mistakenly say the answer is 2. No, 2 is the smallest number that will divide into 24, 36, and 40, but not the smallest number that these will divide into. So the number has to be at least as big as 40. So the first step that we want to do is to factor. When we talk about factoring with constants, we mean prime factor. So we want to write each term as just a product of nothing but prime factors. And we do this by using a factor tree. Once you get a prime number, and as a little review, a prime number is a number that is only divisible by itself and 1, then we are finished with the prime factorization. So let's do the same thing with 36. 2 will go into 36 18 times, 2 will go into 18 9, and 3. So we're finished here. We have a prime factor at the end of each branch. And now let's do the same thing with 40. 2 will go into 40 20 times, 2 will go into 20 10, and 2 will go into 10 5 times. So now we're finished with this. Now our second step is to write the prime factorization of each. So if we look at 24, 24 is 2 cubed times 3. 36 is 2 squared times 3 squared. And 40 is 2 cubed times 5. Our third step is to choose the highest power of each factor and multiply. So let's do that here. So our LCM is going to be the highest power of each factor that we have showing up. If you look, we have a 2 cubed, a 2 squared, and a 2 cubed. The highest power that we see of 2 is 2 cubed. So that gets pulled into our product. Next, notice we have a power of 3, a factor of 3. We have a 3, and if it does not have an exponent, it's assumed to be 1, if you want to write a 1 there. So we have a 3 to the first and a 3 squared. The highest power is 3 squared. Lastly, we have a 5 that shows up, and we just have 1. It has no exponent, so it's assumed to be 5 to the first, so that gets pulled into our product. So our LCM is going to be 2 cubed times 3 squared times 5 to the first. And always with constants, we want to get a number. We want to write that out. So that's simplified. 2 cubed is 8, 3 squared is 9, times 5 gives us 360. So 360 is the LCM of 24, 36, and 40. Well, how do we use that? What does that mean? That means if we had fractions that had denominators of 24, 36, and 40, and we wanted to add them, then 360 would be our least common denominator. It is the smallest number that if you were to list the multiples of 24, multiples of 36, multiples of 40, 360 is the smallest number that would be found in all three lists. Suppose we want to find the LCM of these two rational expressions, m squared minus 5m plus 6 and m squared minus 4m plus 4. Well, same steps. We want to factor each completely. So if we have m squared minus 5m plus 6, we're looking for two numbers that have a product of 6 and a sum of negative 5. So that's going to be m minus 2 times m minus 3. Now let's look at m squared minus 4m plus 4. This also, as the other one was, a trinomial with leading coefficient of 1. So we're looking for two numbers that have a product of positive 4 but a sum of negative 4. That's going to be m minus 2 times m minus 2. So our factorization looks like this. We have m minus 2 times m minus 3. And over here we have m minus 2, and we're going to write that with an exponent of n m minus 2 squared. Now our second step is to choose each factor that appears that has highest exponent. And form a product. And that's going to be our LCM. So our LCM is going to be equal to, I have an m minus 2 with no exponent. So that's to the first power, and an m minus 2 squared. So the factor that gets pulled is m minus 2 squared times, I have an m minus 3 to the first and no m minus 3 over here, so m minus 3 to the first. So this is my LCM. And no need to multiply that out. To put this in perspective, when would I use this? I would use this if I had a rational expression that had a denominator of m squared minus 5m plus 6. And I want to add it to a rational expression that had a denominator of negative m squared minus 4m plus 4. Then my least common denominator would be m minus 2 squared times m minus 3.
Remember, in order to learn math, you've got to do math. You've got this. Class dismissed.